Hi everyone, this is Maverick Phua, the chemistry guru. Now in this video, we want to discuss a more concept question involving combustion analysis of dihydrogen sulfide and carbon disulfide. So the question goes something like this. Gases given off during volcanic eruptions include H2S and CS2. I have a 40 cm3 gaseous sample of these two gases present in a 3:1 ratio respectively, analyzed by combustion using 100 cm3 of oxygen. After measuring the volume of gases remaining, product is treated with excess aqueous sodium hydroxide and the volume of the gas is measured again. Now question did give us this information. Your sulfur present is converted to sulfur dioxide after combustion, and what we want to determine is, given all volume measurements were made under room conditions, what are the measured volumes? So I want to determine volume of gaseous mixture after burning and volume of gaseous mixture after adding sodium hydroxide. Now, let us run through the concept involving this. The topic inside this question is obviously under mole concept, and given 40 cm3 of H2S and CS2, and the ratio for these two guys given is 3:1, and we know that I will have 30 cm3 of H2S and 10 cm3 of CS2. Next thing is we need to balance the equation involving combustion of H2S with oxygen and combustion of CS2 with oxygen. Now what we will have to do is we have to figure out what the products are. The question tells us that sulfur will be converted to SO2. Then how about hydrogen in H2S? Now involving combustion of hydrogen, we should be able to deduce that it should be converted to water. So I think water, it is a reasonable deduction that we will have involving the product that can be formed. Involving combustion that carries hydrogen, the product should be water. And similarly, involving carbon, it is also reasonable for us to deduce that the product involving combustion of carbon should be carbon dioxide. So once we can figure out the products involving combustion of H2S in oxygen and combustion of CS2 with oxygen, then we can balance this equation. So there are two reactions to keep in mind. Equation number one is H2S plus 3/2 O2 to give me water and SO2. And involving reaction number two, CS2 with 3O2 to give me CO2 plus 2 SO2. So once we have the balance equation and we can determine the volume of O2 reacted for reaction number 1 and 2, as well as the volume of the gaseous products that are being formed. Since the mole ratio involving O2 to H2S is 3/2, I have 30 cm3 of H2S. I should be able to calculate that 45 cm3 of O2 will be required. Involving the mole ratio for SO2 to H2S is 1:1. 30 cm3 H2S, if it is used up, I'll form 30 cm3 of SO2. Notice in this case, we are actually not so interested in the volume for water, because water, it is a liquid at room conditions and it will not contribute to the volume of gases. So we can ignore water. Involving CS2, plus 3O2 to give me CO2 plus 2 SO2. Again, we can compare mole ratio. If mole ratio for O2 to CS2 is 3:1, 10 cm3 of CS2 should require 30 cm3 of O2 for reaction. And mole ratio for CO2 to CS2 is 1:1. 10 cm3 CS2 used up, 10 cm3 of CO2 will be produced. And if I compare mole ratio for SO2 to CS2 is 2:1, 10 cm3 of CS2 is required, and I will form 20 cm3 of SO2. So once we have determined the volumes of O2 required and the volumes of the gaseous products that are being formed, remember all the reactants involving CS2 and H2S, they are completely used up. So at the end of the reaction, I wouldn't expect any CS2 or H2S to be present. And we can determine the volumes of all the gases that we're interested in. Total volume of O2 reacted will be 45 cm3 plus 30 cm3 for both reactions number 1 and 2. 75 cm3 of O2 is reacted. Question did tell me that altogether at the beginning I have 100 cm3 of oxygen, so remaining volume of O2 will be 100 minus 75, which is 25 cm3. Volume of carbon dioxide formed in reaction number 2 is 10. Volume of SO2 formed in both reactions, 30 plus 20, which will be 50 cm3. With all these volumes already, we can finally determine what is the volume of gases that I can form after burning. It will be the volume of O2 in excess plus the volume of carbon dioxide that is formed and the volume of SO2 that is formed, which will be 25 plus 10 plus 50. And this will give me a total volume of 85 cm3. After adding sodium hydroxide, now sodium hydroxide is a base. It will be absorbing gases that are acidic, and involving gases that are acidic will be my carbon dioxide and SO2, because both of them are non-metal oxides and non-metal oxides are acidic. These two guys will be acidic and they'll be absorbed by sodium hydroxide. And therefore, the volume left will just be involving my oxygen in excess, which is neutral. I should be left with 25 cm3. Then I can look at my options. A, B, C, D. The answer to this question will be option C, 85 cm3 of gaseous mixture after burning, and 25 cm3 left after adding sodium hydroxide. Alright, so this is the discussion involving combustion analysis for H2S and CS2. So if you have learned something useful from this video, please give me the thumbs up, like this video, and subscribe to my YouTube channel for more weekly video lessons. That's all for now. I'll see you next week.